Let me start. Just 1 second. Let me start that. Okay. Okay. So yeah, it's our pleasure to have Zhiyang to give us a talk about fortifying decentralized systems, a multi-layer approach to blockchain security. Zhiyang is currently a Ph.D. student at University of Toronto. Yeah, you can see his full bio in the Luma. So without further ado, let's welcome Zhiyang for the talk. Thank you.
Thank you very much. Thanks, Yuxi, for the invitation to give this talk. And I think this talk is kind of unofficial, so please feel free to interrupt me anytime. And we will also leave enough time in the end for discussion. Feel free to ask me any questions regarding my research or regarding anything related to blockchain. So today's topic is about the fortifying decentralized system, a multi-layer approach to the blockchain security. Actually, this topic might be not that accurate. So what I want to present here today is I want to present so first I'm going to present in current blockchain ecosystem, the multi-layer architecture of different components. And for each layer, I'm gonna discuss the current security problems or in the past, and also put some possible hacks happened in the past, and how can we address them? How can we use a multi-layer approach to address them, to make the job of hacker harder, so we can see fewer and fewer incidents in future. All right, let's get started. So I assume everyone here has some basic knowledge about blockchain. Since blockchain has been here for about 15 years, since the exposure of this system, and but the hacks are also happening increasingly. As you can see from this picture, it's actually DeFi Llama. It records all the hack incidents since 2017, and as we can see here, the hack incidents are growing. And for this biggest, highest bar in 2020 December, it's Lubian. It's actually stole a lot of Bitcoin. But at that time, the Bitcoin was not worth that much. So this number is not that accurate. But as you can see, since 2021, since Bitcoin price or Ethereum price got so high, we have seen the DeFi summer. Well, by the way, this period is so-called DeFi summer. There are a lot of DeFi applications has been implemented and then built. And we've seen a very active hack incident here. Um, uh, so starting from 2025, we see another summer for the blockchain. As we can see, just a few days ago, the Ethereum price has reached the all-time new high. But in this round, we haven't seen a lot of applications developed. For this round, I think it's mainly pushed by those financial organizations, those banks, or those big companies. But if there are more and more application implemented in near future, it's very likely the same thing happened to DeFi summer in this period will be happening again in the next 1 year or 2 years. This is my personal estimation. So overall here, the blockchain is a growing business and hacks are happening increasingly. The security problems is becoming more and more important. Here I've shown a diagram, a 4-layer diagram of the blockchain ecosystem. So let me do a very brief introduction here. So on the bottom, we have network layer, which is layer 1 blockchain. Layer 1 blockchain basically means a blockchain can function independently. So, and it does not need anything else. It just needs a few nodes. If there are some people running the node, then a blockchain will be maintaining there. This layer, this network layer, is the foundation layer for all the applications built on top of it. So if this layer crashes, then all the application, sidechain, mempool, smart contracts, they will be all gone. And it is also vulnerable. Um, Back in 2016, back in 2016, 2017, it has been discussed a lot. Uh, if you still remember, in 2016, 2017, there are many people who tries to build a new Bitcoin. They try to build a new blockchain. And at that time, there are so many public blockchains. And one question they got frequently asked is how do you solve the 51% attack? How do you solve the consensus failures? How do you solve the network partitioning, node synchronization problems, all those technical problems? Um, I mark this layer as a high risk because this is the most profitable one. This is the hardest to attack, of course, but this is the most profitable one. Suppose you can control the whole blockchain. Suppose you can control the Bitcoin, that chain, that blockchain is very, tempting. You can get all the Bitcoins. You can rewrite all the history. So I think if the incentive is big enough, there'll be always motivations to perform the hacks, even though at a very high cost. All right, this is the layer one blockchain. Some common examples include the Bitcoin, Ethereum, Solana, blah blah, Conflux, blah blah. And then we have, but the layer one blockchain has a problem, which is it usually has a very low throughput. And so the transactions might be very expensive. The transactions might face some congestion. Your transaction from your submitted transaction to actually get finalized on the blockchain might take a lot of time. That's why we have the multiple solutions, multiple scaling solutions for layer one. The first example is, of course, Ethereum, since because Ethereum has the virtual machine on it and has a lot of smart contract, so Ethereum has a lot of transactions. And there are a bunch of teams, a lot of teams trying to develop different scaling solutions for them. Um, it's a side chain is one of the very early efforts, and nowadays the layer twos are very common. There are hundreds of layer twos. There are hundreds of blockchains that build on top of layer one, try to scale the throughput of layer one, the Ethereum. And we've also seen some effort to scale Bitcoin, try to bring the smart contract to Bitcoin, basically the BitVM. There are also a bunch of companies trying to implement that. But it also suffers from its own security challenges. Also, here I also include the cross-chain here because if you have from layer two to layer one, we need some communications. From layer one, from different layer twos, from different layer ones, we also need the communications. This is usually done by the bridge, but for the bridge itself, it also contains vulnerabilities and might suffer a very big financial loss. Um, but overall here, I mark it as medium risk because the impact here is still limited. Um, and the TVL of each layer two is also limited compared to the layer one. Also, it's hard to conduct such a hack compared to layer one, because if you look at the layer twos, all those bridges, cross chains, many of them are centralized, which means they are controlled by one entity. So in the worst case, they might just stop the machine. But for Bitcoin, we certainly cannot stop the Bitcoin. For Ethereum, we certainly cannot stop the Ethereum. But in this case, so we have those administration power to stop it. That's why I mark it as medium risk because we have the power. The third layer is the mempool and sequencer layer. So let me do a brief introduction to the mempool and sequencer. So basically, mempool and sequencer are one part of the blockchain which decide the order of transactions. So this is exposed to all the users. But since all the transactions could be public, other people can see your transaction. So there are MEV attacks to try to change the transaction ordering so to make profit. You will lose some money if they find one opportunity inside your transaction. I'm going to explain it later, sandwich attack, front running attack. So it will affect some individual users. So if you are an individual user of the blockchain, and then you send some transactions which contains a lot of money, um, and also it contains some chances for other people to sandwich you, then you lose some money. Actually, you will lose a lot of money, but in the end, it will only affect individual users. So I mark it as medium risk. So if you lose money, you will only lose maybe 90%. Oh, that's a lot. That's an extreme case. But it will only affect individual users. It won't be very impactful. Um, the fourth layer is the smart contract layer. So smart contract is very short programs that can be written in smart contract languages such as Solidity or Move, and the smart contract are deployed on blockchain as uh, the self-functioning programs. It can contain logical bugs, such as reentrancy, access control, oracle manipulation, integer overflow. It can also contain the front-running vulnerabilities. Um, I mark it as high risk because if you find a bug, it's very likely you can drain all the smart contracts. So not an individual user might be hundreds of thousands of all the users in one protocol, and the impact could be very big. In fact, one vulnerability in smart contract on Ethereum eventually led a hard fork of Ethereum 3, 4 years ago. So because that smart contract actually contained too much ethers, so that's maybe I remember it's 30% of all the ethers at that time. So it's so impactful. Even the Ethereum Foundation themselves have to pay close attention to it and eventually decide to make a hard fork to revert the change done by the hacker. So in the next, I'm gonna for the each layer, I am gonna give some examples for each layer of blockchain system. I'm gonna explain what's the most common attacks on each layer and what are the current state-of-the-art defenses for those attacks on each layer. And on the end, I want to mention the action we can take if we are just a normal user to use the blockchain system. Well, after explaining all of these attacks, there might be some concern of, okay, it's so vulnerable. So why should we use this? But I want to rebuild some confidence in the end by explaining some actions we can do can make us well, probably safe. Because well, it has been developing for over 10 years. It's certainly much safer than the previous DeFi summer 3 years ago. We've seen so many security layers added to the system, which makes the job of hacker extremely hard, but not impossible. It's still possible. Number one, layer one blockchain. Uh, Here, I think I don't need to explain too much. I'm gonna just give some examples. Most famous one is Ethereum. It's the most famous one. It also has a shift from the proof of work to proof of stake. Uh, uh, Proof of stake is actually a good thing for the security. It's a very good thing for security because in the proof of work, there is a chance of the reorganization, which means all of your block will be reverted. Everything you've done can be reverted if another group of people build a longer chain. But proof of stake basically saying your block will be finalized. There will be no change at all later. And so the current period of this proof of stake consensus is about 30 minutes. So if you send a transaction and you wait for about 15 minutes, and then you can basically uh, be 100% sure your transaction will be there forever. It won't be changed unless the whole ecosystem collapses. It also saves the energy. If it's now we switch from the proof of work, so we don't need to do hash, we save a lot of energy. Solana is a very high it's a high performance blockchain. It has a very high throughput compared to Ethereum, and it now also contains a lot of users, and also it has many successful applications, uh, such as Polymarket, if I remember correctly, also Pump Fund. Those successful applications built on Solana really boosts its popularity. Bitcoin, I don't need to explain. Conflux is also another layers based in China to design for scalable and secure smart contract and decentralized applications. It has a high performance. So so the most severe attack, the most severe vulnerability to the layer one blockchain is the reorganization threat. So the reorganization basically means we have now we have this blockchain, right? It maybe contains a number of blocks. And what if there's another group of miners try to build another blockchain, try to build another blockchain here. And if they control more than 51% of the mining power, it is certainly be able to be faster compared to the rest of the miners, so they can build a longer chain. And once they release this longer chain, all the nodes on this world will have to admit, okay, you are the longest chain, and we have to admit you are the mainnet. You are right. Then all the transactions happened on the other chain will be disregarded. So this is very, very dangerous because what if you hide another chain for about 3 months? Then everything other people do within these 3 months will be nothing. In 2018, Verge suffers a 21% attack, resulting in some stolen funds and permanent damage on its reputation. Yeah, it's gonna be it's extremely severe thing for one blockchain. It can end the reputation for one blockchain. Selfish mining is actually an advanced version of 51% attack. It basically says now we actually don't need 51% attack. We don't need 51% computation power. We only need 1/3 of the computation power. Then we can steal um, to gain the unfair advantage, and we can still create a longer chain. It's you can assume the selfish mining can cause the similar reputation damage as a 51% attack. Consensus manipulation, it's if you control basically it's for the proof of stake. Uh, if you can vote and get some unfair advantage, then certainly you can destroy the consensus, and you can build your own consensus and convince other nodes, which is also super dangerous. It means the blockchain will be controlled in a number of people. And some people might think, okay, you are mentioning a lot of the 51 attack, selfish mining, consensus manipulation. These concepts were mentioned 4 years ago, 5 years ago. It's been a very long time. right? And now everything is different. Uh, these attacks are less likely. But I want to say, no, I think it's not the case. Actually, I have observed it's become more and more centralized. So before, maybe 3 years before, where not a lot of people knows blockchain, so they are just running it on their normal computers. But now, more and more advanced ASICs or mining machine were developed, and many of them are using AWS, right? If it's not proof of work, if it's proof of stake, then many nodes, majority of the nodes are actually using AWS. Then AWS has this power. So what if AWS do something evil, right? And so yeah, it's still gonna be a very big problem, even under today's situation. Um, the threat become practical. Okay, yeah. So the 51% of attacks, it's of course it will cost some money to do it. And the key thing here is whether the incentive is big enough. Um, if the TVL of blockchain is growing again and again, eventually it will reach one day that doing this 51% attack will be more profitable. And the smaller chains, the chains with low overall hash rate security, will be exploited first. The smaller chain, yeah, as we've seen in the past, the Bitcoin Gold suffered the attack in 2018. And just recently, 4 days ago, 4 days ago, there is a very suspicious attack on Monero. So Monero blockchain is also very big. It is, I just checked the coin market cap. It's actually the number 30 blockchains in terms of the total value locked. And there is a security company, Slow Mist, reported Monero under 51% attack. One mining pool controls more than 50% of the hash power. Um, This is not the reason why Slow Mist claimed that is they seeing 6 or 8 blocks being reorged. This is not a very big number, but it is big enough to raise the possibility of a 51% attack. I cannot say it is 100% true because there are a lot of people try to clarify things. A lot of people try to say, okay, you're wrong. We're not, this is just normal cases. This is just extremely edge case because they know if it's eventually confirmed it's a 51% attack, then it's going to cause a very big reputation damage. And basically their chain will be destroyed. No one will use their blockchain. It's super dangerous. Uh, we've also seen a very big price drop. I'm not sure if it's because of this, but I just want to make it clear this is not something impossible. It is happening um, nowadays as well. We have some ways to defend this 51% attack and selfish mining. The first one is certainly high decentralization, which are distributing mining or staking power widely to make it difficult for any single entity to control more than 50% of network resources. This is actually concerning because if you look at the mining pool themselves, not one single mining pool will control more than maybe 30% of the computation power. But who behind them are not sure. So it could be one person behind multiple mining pools. So eventually it's controlled by the single entity. And also, blockchain allows you to stay anonymous in many cases. So, I mean, in real world cases, we can also stay anonymous by routing your voting power. Um, but well, it's it's like a slogan, high decentralization. But indeed, if we have this indeed truly high decentralization, this problem can be solved. The POS, the proof of stake, also provides some economic incentive. If you did something evil, they're gonna slash your staked assets. Uh, it's just one way to protect the integrity of the blockchain by using economic incentives. Uh, but POS introduces finality. If we have the finality, then the biggest thing we can sacrifice is only 30 minutes. After 30 minutes, all the transaction will be finalized, all the block will be finalized, so nothing to worry about. Or if there are some blockchain does not want to sacrifice their old design of the proof of work, they could also consider combining the proof of work and proof of stake, or another finality layers, such as Ethereum's merge, to raise the cost and complexity of sustained attacks. For example, Conflux adopted a similar approach of doing that. They combine the proof of stake and proof of work to make it less vulnerable to the selfish mining or 51% attack. But that's for the layer one. As we can see, actually, as a normal user, we cannot do anything about it. This is something because you cannot change the code of layer one. Um, the layer one themselves should be aware of the issue, and they should be constantly monitoring their nodes who control the most voting power or control the most computation power. Mm. Okay, let's move on to the second part, the scaling solutions. So there are a lot of layer twos. If you check L2 bits, there are already 100 layer twos, and there might be another 50 layer two blockchains coming. They're still building it. There are multiple solutions. There are multiple like implementations or design choices. The most popular one is rollups. Rollups consists of two types, the optimistic rollup and the decay rollup. The sidechain is some old effort to try to scale it. We also have BitVM. So layer twos are built on top of layer one, which means it suffers the same security vulnerability of layer one. And because it's also a blockchain, so it also suffers some common vulnerabilities of a blockchain, such as denial of service. But the good thing of layer two is layer two does not have to be decentralized. It is just a scaling solution provided by some entities. So it really does not have to be decentralized. You can dramatically increase the transaction speed and you have the administrative power to stop anything evil happen on your chain. Mm. But for the cross-chain vulnerabilities, that's actually something all the layer twos should worry because we need some communications between layer one and layer two. And to be a layer two, you are required to submit your proof on layer one. Also submit your final blockchain state after each block on layer one. So you need to submit a lot on layer one. So you yourself has another finality time beside the finality time of layer one, which makes the denial of service possible. Um, the other people could possibly try to flood layer twos with a bunch of transactions and to stop normal users from submitting transactions. And because of the DA of layer one is very cheap, um, the hackers can also choose to flood DA of layer one. This is the data availability issues DA. this is a common problems of all the decay rollups. They are working on that. But for now, this risk still exists, even though we haven't seen any real-world attack on that. Also, the bridge vulnerabilities. Uh, Usually, the bridge will contain a lot of tokens. It will contain a lot of TVL. And if one vulnerability happened on bridge, it could lost 2 billion, over $2 billion, as we've seen in the past. A lot of hacks are because of one small bug inside the bridge, and then they just lost all the assets. So the lessons here is, yeah, let me quote from Vitalik: "Don't bridge assets to chains you're not actively using." So also, even if you bridge your asset to that chain, remember to bridge it back. Otherwise, you might not be able to bridge it back if the bridge got hacked. Also, don't actually. Here are a few lessons uh, we can to defend this kind of layer two or cross-chain attacks. We so Okay, so here is a rollups allow users to post transaction directly on layer one if layer two sequencer fail or are censored. So this is called escape hash. Um, if you are really worried about the the denial of service of layer two, what if they just disappear? Then how can if they just disable off their RPC endpoints or there's no nodes running, how can I get my money back? Um, they provide a solution called escape hash. You can submit a transaction directly on layer one, and the layer two will have to, they're forced to include their transactions. So, which makes the denial of service attack very expensive, which also means you have this kind of escape channel, which means you can withdraw your asset even though it's under attack. You can submit something on layer one and then get your assets back from layer two. So when you choose the layer two to use, please consider choosing the layer to enable this feature. Also, sequencer decentralization. If we have a decentralized sequencer, of course, it's going to reduce the denial of service attack surface because now we have multiple sequencer. If one sequencer got some denial of service attack, you can try to reach to another sequencer. But as far as I know, nowadays they're still using one sequencer. Um, I am not aware of any layer twos having multiple ones. I know Taco is trying to have decentralized sequencers, but I haven't remembered they actually achieved that. And also, most important thing, don't leave large sums on a bridge. If you bridge something, you just bridge it to a wallet. Don't trust the bridge will keep your money. They might be hacked, and then you will lose your money forever. Decentralized. Change period. Okay, I think I will skip this because this defense is for the layer twos. It's not for normal users. And I assume no one here tries to build a layer two. Uh, okay, now I think I'm gonna dive into the part three, mempool and sequencer, and the part four, a smart contract, which should be closer to normal users here. We have mempool. Some brief introduction. What is mempool? Mempool is a very temporal storage pool where some pending layer two or layer one transactions wait before being processed. Uh, Act as a buffer between the user submitting transactions and the sequencer organizing them into blocks. For the layer twos, mempool are usually not public to anyone, or there might be some differences. So different layer twos might have different different decisions, but they're, as far as I know, the majority of them does not allow other users to know what's inside the mempool because it's centralized. But there is a trust issue here, which is what if you as the entity running the layer two sequencer, what if you do some evil things? So we cannot trust you as well. It's fair, but this problem is becoming more severe when it's in the layer one because everybody can run a layer one node and everybody should have the access to mempool. And if you submit your transactions through the mempool, then certainly everybody can see your transaction. The sequencer is a layer two unique thing. It's responsible for ordering transactions for sure, and creating blocks and submitting proof to layer one for verification finality. Uh, Overall, here are two risks. Number one, mempool is public to everyone on layer chain, on layer one, which means other layer one users might conduct some hacks on your transaction if your transaction itself is vulnerable. Number two, the sequencer can do evil things. We should not put 100% trust on the sequencer. All right. So the MEV attack, this is the most typical attack happened on the mempool. Um, Front running, back running sandwich. So it's actually a very, I think, clear analogy of how it works. So if you have a transaction which is vulnerable, we will see an example later. And another user, a potential hacker, could submit two transactions, one before you, one after you, and make it a bundle consisting of multiple transactions, and then submit again and try to uh, went through a auction process and eventually be accepted by the blockchain. One example here would be, okay, there's actually a business, a service for it. It's called Flashbots, and it has been very, very popular to, they just commercialize this whole market. So the searchers are uh, all right. I think I need to explain what's MEV. So MEV represents for maximal extractable value, um, which means the the value you can, the profit you can get from a vulnerable transaction if that's public. Um, Here, the searchers are identifying those MEV opportunities. Essentially, they're identifying those transactions. And the builders are will construct blocks with, well, they choose different bundles and then eventually making them one block. They try to maximize their profit, of course. And then the relays connect the builders with validators, where validators and miners will include the profitable blocks. So each party here will be benefited from the MEV, and the people who lose the money is the original transaction sender who originally sent the transaction. And it has extracted a lot of money over it. And I remember Binance Smart Chain, BSC, they have a very similar thing. It's called 48 Club, something like that. And they're doing very similar things to extract values from the user. And this is still ongoing. This year, March 13, we've seen a trader lost over 200K in a swap. So the mistake, this is also a common mistake made by so many people, is they try to swap a very big amount of money. In this case, it's 220K USDC for USDT. Like, well, in some common sense, USDC to USDT should be approximately 1 to 1. It's right, it's right. But the thing here is the poor victim, they set the slippage tolerance too high. So they're saying, okay, the slippage tolerance basically saying, okay, I can allow the conversion rate to be really bad. I can allow a very bad conversion rate, but actually, I believe in his or her mind, he believes I can tolerate a lot, but you should give me a rate close to 1 to 1. No, that's not the case. Other people can exploit this opportunity and then send some transactions before and after you, and eventually this poor trader only gets 5K USDT back. So it has lost over $200K dollars. It's still happening. There are still some poor users will make this mistake, and then the MVP will benefit from it. So what can we do to mitigate the MEV? As a normal user, we can submit to some private mempools or some encrypted transactions. So only you and the blockchain itself can know your transaction. So no other parties in the middle can censor your transaction. But I've heard some stories that even the blockchain builder themselves, so basically some insiders, they still exploit these opportunities. Just to be very careful when choose a blockchain. If there are indeed some insider doing evil things, and also that blockchain it happened to be a super centralized one, then you can never get it right because your transaction are always public to them. We can, for Flashbot and MEV Share, there are some public website you can check. You also have just pay some extra money and they will allow you to bypass public mempool. So reducing the front running risks. So if you are really having transactions of a very high financial values, please choose those private relays and private mempools. Um, Transaction can be hash. Okay, this is actually another thing. This is um, the commit review schemes are not something universally applicable for all the blockchain. It's only possible if that blockchain have designed that feature. So we can skip it. Uncalled MEV process batch. Okay, this slides basically tell you how a searcher could make profit from it. How can they force the ordering? I think we should skip. All right. Not finally. Actually, the second last part is the smart contract. Smart contract is what I research, so I'm very familiar with that. We can chat a little bit more about it. So the history of smart contracts are executing code deployed on blockchains that can automatically enforce rules and agreements without requiring intermediates. It has over 10 years history, and it has many successful applications. It also has a lot of applications being hacked, and its execution is on the Ethereum virtual machine that will interpret code securely with some deterministic outcome. Yeah. Um, it has a lot of attacks. Code is law until it is not. So we've seen a lot of hacks. The reentrancy attack, that's the one attack lead to the Ethereum hard fork. It's a if you compare to now, it is not a lot of money, but at that time, it's just will destroy the 1/3 of all the Ethereum. So they have to do something to do a hard fork. We also have economic attacks. This is actually one thing unique on the blockchain because you can program your smart contract to do something normal financial market you cannot do. So many newcomers will make this mistake. Like they have some very wrong assumption. For example, they may have assumption like my little poor protocol, how can my protocol have $1 billion deposited into it? So I should ignore it. I can safely assume my protocol will only have 3 million TVL. No, that's not the case. In the blockchain world, people can borrow $1 billion in one transaction and pay it back. That's called flash loan. So you cannot have this assumption. You should have to be super careful about your smart contract. and consider all the possibilities. And potentially, you should ask some security experts to help you with that. This is one example of the reentrancy attack. I'm not gonna dive into details, but I'm gonna just give a very rough idea. So this one is actually telling you to they just forget one possibility, which is not so popular in the uh, in other program languages, but this is the vulnerability inside the blockchain. So that possibility is called reentrancy. Now it's becoming famous, but initially when we've seen this reentrancy attack, it really shocks the whole ecosystem because no one would ever think it can happen. This is a very unique thing of this very unique virtual machine. So currently, the state of the smart contract attack defenses are if you build some smart contract before deploy it, you will ask for some companies to do a comprehensive audits. Um, the auditors could use different tools. They could use formal verifications. They could use some other third-party tools to identify vulnerabilities. This is the most common one. And beside this audit, what you can do is you can also add some runtime validation code. So it's basically adding some code inside your smart contract to detect some anomalies. So once some anomalies are detected, you do some you do something. For example, you stop your protocol. You're saying, okay, we do not accept any new users doing anything fancy. We just stop the protocol until an administrator come and check, okay, everything works fine. Then we resume the protocol. That's runtime verification. And that's also part of the emergency control. So you can also hire a third party to do this monitoring thing to monitor, okay, whether your protocol have a problem or not. And if there is a problem, then that third party company should do what action to make it um, to stop it, to mitigate the exploits. Because usually um, once you're so so nowadays it's very hard for hacker to get your like completely drain your protocol like in one transaction. It usually takes maybe minutes of continuous hack to steal all of your money. Even though you lose some money at the beginning, maybe lose maybe 10% of all the TVL of your protocol, it still takes some time for them to take off it because of the market's fluctuation. So you have some time to respond. You can hire some third party to do it. You can also um, add some runtime validation. So we've done some research on it. It's actually a paper published in FSE, sorry, 2024. It's wrong. It's a paper try to demystifying all the runtime validation methods. I'm gonna briefly chat about it. So the smart contract has a concept called DeFi Lego. So basically, my protocol will be built on top of some other protocols. So their protocols serve as the infrastructure. So I only invoke some functions from those smart contracts. Um, but I cannot just blindly read their outputs. They could be lying to me. They might be honest. Some hackers could force them to lie. For example, for Oracle, some hackers can manipulate the price to force Oracle to lie. Or some hackers could, cause some denial of service so the Oracle is not updated uh, real time. So there is a delay. So they might be honest, but I just cannot completely blindly trust them because they are not the code written by me, they're the code written by some others, so I cannot trust it. So what can we do? But we have to rely on them. It makes no sense for us to build the whole infrastructure all again. What can we do? We add some runtime guards. So basically saying for all the integration, we trust nothing. Even the user, we don't trust you. We add some code to define some state which I believe is normal. If it's within its normal range, you are safe. I allow you to use my protocol. If it's something abnormal, I I will stop the execution. We will stop. We will even stop the protocol. Actually, it works. Um, and also, it's something widely used in the developers. We have checked a lot of audit reports. We have also searched a lot of code repositories of these audited projects. It's already a common strategy. Like nearly all the protocols will at least use one of them. For example, some common ways, I assume the user only invoke my protocol following my way. Because in the world of smart contract, in the world of blockchain, the users can deploy another smart contract and do some very magic things, very weird things like I never think of. The developers just said, okay, forget about it. You have to follow my way. You have to use my protocol following my way. I do not allow you to freely use my protocol as you like. So I will only accept transactions sent from wallet. Basically, it's a direct invocation. Or if the oracle, I can define a range. I can say, okay, I think the price fluctuation within this range should be fine. I allow it. But if you give me a value which is substantially different from the previous one, I'm gonna report it. I'm gonna stop my protocol. I'm gonna reject all the Oracle prices you gave to me. I think you're no longer trusted. The same thing also applied to other DeFi protocols. Here's one example. It's called data flow upper bound. This vault is from another project. So this is something not trusted. Um, Actually here, it contains two variables, invested balance and total balance. It has a upper bound. It says, okay, the value you returned should never exceed the upper bound I defined. If you exceed that upper bound, I think it's completely nonsense. Please stop it. I'm gonna reverse the transaction. The transaction will be not allowed. The same thing happened to users, which we would assume the user sent only from the wallet to define somehow a safe zone for all the other dependencies we're not so trusted. Okay, that's a smart contract. Smart contract is of high risk because if you have a bug, then all the money are gone. Like all the users of your protocols, they might invest their life savings on you, and then now they got drained. The similar tragedies happened multiple times during the previous DeFi summer. Um, but hopefully in the future it's gonna be easier. Okay, in the end, I'm gonna introduce some new threats which we haven't seen before. Uh, it's um, it's very I would say it's something really happened because of ChatGPT. It's something really happened because large language model indeed changed this whole technology roadmap a lot, and this technique can be used in an evil way. Um, and Web3 could be an evil place to use this evil technique. Um, we have seen so many new threats, new hacks. Uh, I hope I can raise your concern and be aware of okay, such hack indeed exists. So first of all, private key leakage and phishing, human and endpoint weakness. It's like the private key, everybody knows private key is so important. If other people know your private key, they will drain your wallet. But now there are so many phishing traps to phish your wallet keys. There are so many phish attacks. If you have a time, I would encourage you to open this URL. I can open it right now. I tell you this is a phishing example. It still existed, and this is a phishing one. Let me do it actually right now. I just want to show you now the phishing website is so good. Indeed, so good. Like previously, when we are saying it's phishing website, we can actually tell it because it's so unprofessional. Building one beautiful website, building one official website takes a lot of time, takes a lot of engineers doing a lot of work. And if you are just trying to fishing for a fishing purpose, your website could be very simple. Like we can tell the difference. It contains a lot of bugs. It sometimes the fonts are too big or too small. It's just not certainly not fine-tuned for production ready level. But now after ChatGPT, they look so real. They look so authentic. Even I cannot distinguish it. It really needs some domain knowledge to expert knowledge to understand, okay, this is something not right. This is not something actually um, what should be done. Let me actually open this web page on my laptop. I want to show you how real it is. Okay, so this is a documentation. Again, I'm telling you, this is a phishing website. This don't trust any information from this website, but this website indeed exists. It's already reported to some phishing guards attempts. So if you install those or wallet guards or those you should be fine. You should be blocked from this. So this is an open source toolkit, and this API is malicious. If you use this API, if you strictly follow what they told you to buy SPL tokens, let's click on buy SPL tokens. Yeah, this is the API they provide you to, you need to give them your private key. You need to give them the token contract address, amount of Solana, but the only thing here is a private key. The most important thing here is a private key. But they make it so real, like you even have to tip it, right? So Boolean flag to indicate a buyer operation. They are so kind. They even provide you with a code snippet example. So you don't need to do anything. You just need to copy and paste. They provide a Python code snippet. They provide a Node.js code snippet. But if you use this endpoint, you're passing your private key to it, and then all your Solana wallet will be drained. And there are actually people complaining about it. I'm pretty sure there are people complaining about it on Reddit. Let's search it. Uh, the the Reddit. But yeah, there are some people complaining on the Twitter. There are people saying, okay, this is scam, right? There are some security experts like me trying to spread this information as far as possible. But there are still, if you search it, if I search Solana APIs, okay, if I have a space in the middle, then the results are much more trustworthy. But in some case, if I only type Solana APIs, this documentation only still pops as the first result of Google. And the first one, the second one, they're all fake. Which means now they even have a Medium article advertising how good their API is. Let's take a look. So yeah, they have a link direct you to their documentation. And their documentation, it looks so real. It's certainly generated by some API. It's just some large language models with the help of large language models. So this is one thing we find very dangerous right now, and very well, we need some raise some concern. And for the hardware wallets, and okay, the human and government factors in blockchain security. So okay, so here basically I want to say there is also some human attacks. We've seen some scams or some efforts, like because nowadays AI can help you to fake your face, right? So even though probably they cannot do a presentation like me, but it's very easy for them to make me moving and saying nothing, with my if they have my headshot, they can do it. And then there was a trap. There was a scam. There was a actually real incident happened here. A Web3 founder, its co-founder, uh, like having a Zoom meeting with him, and then he can only see his co-founder is trying to say something, but he cannot hear it. And his co-founder is typing like my mic is wrong, is broken. So what about we switch a platform and send a link to this Web3 founder, and this Web3 founder click that link, and then his wallet got drained. So it is a combination. So as a Web3 founder, I believe he certainly have some awareness of how dangerous it is to click a link, phishing link, potentially phishing link. But you have this, human trust because of you already see your co-founder's face from Zoom, and trust it and click the link. It still got drained. Um, yeah, that's the case, and we've seen it's gonna be increasingly popular, I would say. This is also another. I cannot categorize into all the four layers here, but indeed, this social attack is very important and very, very concerning. We also have this human and governance factors in blockchain security. Yes, what if somebody can pretend to be somebody else? What if they can borrow their governance power to conduct the community votes? So, all right, I'm gonna close this presentation by introducing some actions we can do. I think the closest things to the normal users are number one, sandwich attack. So I think it's a very common thing for us to swap one token for another. Just be very aware. What you got you become vulnerable when you are trading large trade amounts and you allow very high slippage settings. And then you're also trading on public mempool and popular trading pairs because public trading pairs, there are so many people listening to it. So it's very likely your transaction will be discovered by some searchers. And the practical defense strategy is to split your large trades into smaller ones and do it slowly. So even if your first transaction got sandwiches, you still realize, okay, it could be hacked. So I should be using another way of doing it. Um, this is swapping. This is just example. Okay, there are also a couple of ways. The flashbots or cow swap. These are all the protocols developed to fight against this scenario. We also sure we have to choose very secure infrastructures and use only trusted, audited, well-known wallets, MetaMask. But be aware, there are so many websites or plugins try to pretend to be MetaMask. Remember to find the official website. Um, and RPC providers, Alchemy, stay updated. Yes, for sure. Trust those RPC and wallets which has existed over 5 years. So they should consider the most of the situations you will be fine. I think it's the similar things. All right, I think that's the end of my presentation. I hope everybody learned something. Um, I am welcoming any questions.
Yeah, thanks a lot for Zhiyang's uh, excellent talk. I think it should be very accessible to even non-technical people. It's a nice
Okay, nice, nice.
overview of of this field. Yeah.
Yeah,
Yeah, and people have any questions?
First of all, thank you for giving us such an informative presentation. I like your presentation very much. So I'm the first time to come here, so just would like to know, like, where will you put your following event information? Like, I would like to attend more presentation like this.
I
Oh,
think we have a WeChat group, right?
yeah. Actually, you check my. I'll put that in the chat shortly. Yeah.
Yeah, cool. I can join that WeChat group so
Yeah.
we can keep connected.
Yeah. Okay. Um. Yeah. Actually, since you do not say a lot about technical stuff, maybe I want to ask. Would you like to say a little bit more about you? I think you just mentioned one paper, right? Can you say a little bit more about your paper?
Oh,
Maybe
sure.
more technical stuff.
Yeah, so I just feel like if I talk a lot of technical stuff, people will get bored. Um, for this paper, yeah, demystifying invariant effective for securing smart contracts. This paper actually has multiple contributions. Um, I think the first one is we okay, so now as a developer, how do we see the transactions? Usually we use Falcon, right? People, if you're a developer, you probably will use Falcon to read the transactions. Or like if you're old enough like me, you probably still remember there's an open chain. You can use OpenChain to read transactions, but unfortunately, OpenChain is no longer valid. Is no longer available anymore. But now we have to use the Falcon to read the transactions. So the thing is, we need to understand our users. We need to understand how our users are using our protocol. Um, the hackers certainly use our protocol in a different way compared to normal users. A very different way. Probably, in many cases, hacker will use a substantially higher amount, financial amount, compared to normal users. So normal users will only deposit 500, 1,000, 2,000, but a hacker will just deposit the $1 million and then withdraw $3 million. So that's very abnormal. And what we do here is first we develop a tool to extract user behavior from the transactions. We build a tool. Falcon is closed source, and we built a tool called Open Tracer. We built a tool called Open Tracer to visualize it. We can build some very similar to Falcon. We can build the invocation tree like this, including all the uh, contracts, the function call, and also all the storage, S load and SS store. We also decode the mapping. So with this data, we can better analyze what each user is doing in each transaction. How did they use our protocol, and uh, what did those transactions change the state of our protocol? We can do a better monitoring. That's the first thing we do. After we understand our user more, after we understand the protocol more, we are then introducing those guards. There are actually 8 categories of invariant guards. We extracted from the different literature, and then we're saying, okay, how about inferring those guards dynamically? We collect the information from the past transactions, and we just automatically infer those invariant guards and recommend to the users, recommend to the developers, and developers can deploy those guards sometime later to better protect their protocol. Um, this is impossible before because before the smart contracts are immutable. You cannot change the source code. But after after there are a design called upgradable smart contract, after that, you are free to change your code as long as you don't change the storage slot, which we don't. So, which makes this work extremely interesting is we show only adding very similar invariant guards, maybe one line or lines of code, we can stop 90% of the hacks with very little false positives. Like the users will be affected very minimum. That's the good thing about this work.
Oh, yeah. I think there's a question. Let me see.
Really? In the chat?
Yeah.
Could you read it? I
Could
cannot.
you explain more about how the abnormal behavior could lead to loss of tokens?
Okay. could you explain more about how abnormal could be lead to loss of tokens? Okay, sure, sure, of course. Your bit loss, sure. We lose loss of token abnormal. Okay, so let's say, let me give you a few examples. So so first, let me give you a fact, a surprising fact. 50% of the hack, when the hack happened, the hacker is the only one who used another smart contract to invoke the protocol, to invoke the victim protocol. So, so this is the only, so there are basically two types of users of your protocol. Number one, they just follow what you told them to do. They invoke one function of your smart contract. Then they give your money, they give their money to you, and then you do some maybe some yield earning, whatever, and then later they will try to withdraw it. So one transaction, one function. That's the most normal cases. And the hacker will do it very abnormally. Hacker will do, because hackers are experienced ones, hackers are technical, so they will build another smart contract to invoke your smart contract, which means they can do more abnormal things. They can do 10 withdrawal, or they can do 10 deposits and 10 withdrawals in one transaction. So they deposit $1 million, withdraw $2 million, deposit $1 million again, withdraw 2 million again, and then do this back and forth for maybe 13 times. This is certainly different from the normal users. The normal users, what we have seen, they will deposit $500, withdraw maybe $600, a very small amount of money. But the hacker, because they can use other tools like flash loan, so they're using substantially more tokens compared to the users, and also they can do it multiple times. And how can that lead to the loss of tokens? Because they find a vulnerability here. For example, for Oracle manipulation, they can use a lot of tokens to manipulate the Oracle. So if the protocol is reading the states from the Uniswap, they can use tokens to manipulate the Uniswap first, then drain tokens from your protocol, then revert it back. Usually it works in that way. So I manipulate the Uniswap, I deposit, I manipulate it back to normal state, I withdraw it. I manipulate it again, Uniswap, and then I deposit. I manipulate it back, and I withdraw it. So, but as a protocol, as a smart contract itself, it's very hard for me to tell whether Uniswap is manipulated. What I can only see is the result given by the oracles. So, and also, even if I implement some guard here, um, they can see how they can see, because my guard is public, right? Our code is open source. So they can see how I protect against these oracles. They can still conduct this hack, even though in a smaller amount. So overall idea is once there's a vulnerability inside your protocol, the hackers can do very abnormal things to manipulate your to hack your protocol, which is completely different from what normal users will do.
Yes, just now you saw the example, the API. I think that I'm kind of surprised, they even ask the private key. I think that's a common sense for many people, right?
Oh,
Usually, yeah.
no, no. I mean, the interesting thing is the reason why I find this example is ChatGPT recommended to some people, and people
Oh,
just use it. Look,
really?
yeah, let's look at the example. So this is a real world example. Some people already lost $2K for 2K USD because of it. So ChatGPT will read from online documentation and it will give code to people, right? And for many people, they just blindly accept what OpenAI gave it to it, right? If OpenAI tell me, okay, this is the code I write it for you, and then you just blindly click accept. If you are using Cloud Code or Cursor, I think you have some similar experience. You want read very carefully about every line of code returned by OpenAI or by Cloud because there are too many of them. So this is a code written by ChatGPT, and this poor guy just copy and paste, and then he got hacked to $2,000. So
Okay. Yeah, that's surprised. I
yeah,
think that's a common sense for, people with some background of smart contract or cryptography, right? A private key should be kept private.
but if you think about it, it makes sense because if you want to trade, for example, if you want to trade on Binance, right, using your program, you have to give them your private key.
Okay.
So it's maybe not called private key, it may call token, something like access token, something similar. But you should give them the at least some permission to trade your token.
Okay. Yeah. Yeah, maybe another issue is, nowadays, language model are so popular and, like, uh, English as program language, web coding, and lots of people are using language model to write code. Yeah, how do you like those? Especially, you're a security person.
Oh yeah, sure. I think me, including people around me, we are using it quite extensively. And we don't read the code. We just check the result.
Uh, but you don't read the code? I mean, you don't read the code
I
before
I
you.
I only read code when there's a problem. When I realize the output message is something I did not expect, then I'll have to read the code to find the problem and then teach them, I'll tell them how to fix it.
Okay.
But certainly in this case is special. I think if OpenAI give me that code, I will check. Okay, this private key is important. I need to control which resource I need to give to OpenAI. But certainly it could be I could make mistake if there are hundreds of lines of codes.
Okay. Yeah, there's a comment. I wonder if you could just ask language model to get you some random people's address and the private key.
No, no, no. Yeah, I think someone tried. I haven't tried, but I think someone tried before. It's nonsense. It will generate nonsense.
Sometimes maybe it works, right?
No, it won't work because it's well, or maybe it's public information. If there are already some people leak it publicly, probably you can get it, and the larger model happen to memorize it, then for sure there is a possibility. Uh, yeah, but it's not gonna use to hack the system. It's the private key is still yeah, trust the cryptography.
Yeah, I think, for the smart contract, yeah, also that's also your expertise. I want to read something like smart contract is neither smart nor contract. Anyway, uh, I think, that's pretty, since smart contract is supposed to be executed automatically. So I think
Mhm.
the security, the verification should be very important. So, but on the other hand, how about the current tools for writing smart contract? So once you write it, are you sure it's fully verified, or at least is robust against all the current security attacks or not? Or other good tools to do those things those
Yeah,
days?
there are tools. There are a lot of tools used by also by auditors. You can run it yourself. But okay, for example, Slicer, right? Slicer, smart contract. This is static analysis tool, which a lot of people are using it. And you can scan your smart contract and it will tell you some potential problems. And also, there are, well, the thing is to use these tools, you yourself need to be very experienced. You need to understand it. Sometimes you need to learn it. For
Oh,
example, there's a tool called Citara. I think there's a let me check. I think they have a website, Citara website. This is a formal verification company for smart contract.
yeah.
So they have this Citara prover.
So you need some expertise to use those tools.
Yeah, yes. I think you look, you at least need to know SMT solver to do it.
Yeah, yeah, yeah. Okay. So
But
yeah, pretty involved. It needs lots of background knowledge to be a good smart contract developer. I mean, yeah.
yeah, if you want to be an auditor, yes, you need to learn something. If you want to verify your own, if you can want to formally verify your smart contract, sure, you have to be an expert.
How much do you think the current language model will be helpful?
I know there are some attempts trying to um, use LLM to do the job of auditor. I've seen it. It's called, I think there's a GitHub repo even, some LLM
Yeah,
auditor.
it's a popular topic, so many people will try that these
Yeah,
days.
yeah, look, there's a LLM agent trying to generate bugs. From what I can see, I think it can help finding some low-hanging fruit, but cannot find deep bugs.
Some simple bugs or some common bugs, right?
Mhm. Like static analysis.
Yeah, common things, maybe common. The language model is basically pattern recognition. So if there are already lots of examples on the internet, so maybe it can help. For not very good programmers,
Hmm. Yes,
maybe that's helpful,
indeed,
right? Yeah,
indeed.
yeah, that's my understanding.
Mm.
Yeah. I don't know if there are questions. Maybe let me ask one maybe final question.
Sure.
What's your outlook for say this field, or what do you think may be important? What kind of topics may be important
You tell me off topic or what?
of this say security of blockchain or smart contract?
Oh, you mean the
What maybe important topics or important tools, important method,
in the future?
yeah, in the near future, near maybe long future,
Uh,
remote.
okay, that's a tough question. Um, in the field of security, I think, yeah, I think the reasoning, well, from what I can see now, is certainly the reasoning. There was a dream, or like, okay, so I think it was a dream for many formal verification people try to make formal verification really applicable. But the very bad thing about formal verifications, you have to be, as we've seen this Citara prover, you have to know a lot of things to use this formal verification, which means you need to first hire some PhDs to do the work. Then you can apply for formal verification, which really stops, large scale adoption of formal verification. And you need to write some, to annotate something to the code. You need to, somehow translate the code into a way a solver can understand, some translate it into SMT form or SAT form. So it's really impedes the adoption of form verification. But I think there's one way to do it is to, how about we ask LLM to do it for us? How about we ask LLM to formalize those for us to do the translation work? And we only accept the results once we find the translated formal transmitted formal description are verified by those solvers. So in that case, I think large scale adoption is no longer a problem because the bar has been lowered so much. I can see there might be some interesting breakthrough or the change of the whole landscape.
Okay. Yeah, I think I have one comment is Maybe your first part is I think maybe the UI UX is important for formal verification because the learning curve is so steep. So
Mm,
we need something, some good tool, right? Some good UI UX for not so technical people to use those formal verification. Another part, to be honest, I'm kind of a critic of learning models because they cannot guarantee correctness, but formal verification require correctness. So I think yeah, learning model maybe serve as the UI stuff because they can do natural language communication. In this sense, is helpful. On the other hand, we need to make sure the input and output are correct
mhm.
with learning model. If so, then
Well, we can have for example, we can have a verifier and ask it to try 100 times.
yeah, okay, yeah.
Yeah, right. Or like do it piece by piece if it's really a hard thing. Or human in the loop.
Yeah, yeah, that's possible. That's yeah, also what I'm thinking. Yeah,
Mhm.
yeah, that's great. Uh, Something more? Or
Yeah, I'm very looking forward to what's gonna happen in the next 5 years.
okay. So, are there more questions? Maybe let me count from 3 to 1. 3, 2, 1. Okay. Yeah. So yes. Thanks, yeah, a lot for the I think a very accessible overview of this security for blockchain, in particular smart chart. Yeah, thanks a lot for the talk.
Yeah, feel free to reach out to me.
Yeah,
I can,
yeah,
yeah,
I'll put your information online.
you can find me on WeChat. You can also send me emails. Just
Yeah,
search me. I think you'll find me on internet as well.
yeah, okay. Thank you. Thank
Yeah,
you.
no problem.
Yeah,
I think we can end it here.
okay. Maybe, yeah, thank you.
Mm.
Thank you.
Yeah, thank you as well for the question.